The next use case is Simplified Branch. And we'll talk a little bit about some of the enhancements we've made around that framework of putting firewalls at branch locations. So we have worked to simplify the deployment at branch locations. We have some like dual ISP support natively now. I forget, was it ECMP, I believe is the protocol for doing that. That's natively built in now. We have some options for doing direct internet access. So traditionally, right, if you have a branch location, a smaller college building or something that's in a different city, you need to backhaul it to campus. Normally you would have some kind of private or semi-private type fiber run where you're doing an IPsec tunnel back. There's cost associated with all those things in terms of performance and just monthly spend. And nowadays, if all the things maybe in that scenario, the students, or if it's a commercial entity, all of my employees, maybe they're just going to OneDrive all day anyway, and going to Office 365, or they're going to Salesforce, or they're going to all these tools that live in the cloud. So I'm forcing, at an expense, all of the traffic back to headquarters, so I can just send it right back up. And there's probably still some traffic I want to force back, but maybe some of it I want to just let it get out. So we have some new tools for doing that type of stuff as well. And then managing remote devices has gotten a lot easier. I think it was in 6.7 we rolled out the feature to do data interface management. So you can now manage a firewall on any designated data interface instead of needing a direct out-of-band management interface. So that's very nice, right? And that's what allows our cloud management to work as well. Yeah, it's a very nice feature to be able to have. So the idea of direct internet access, is that Office 365 traffic or whatever. I want it just to go straight to the internet. I want other things to go via a different path. We have also a concept of intelligent routing using path monitoring. So you'll see in a second as I do a demo here of what's called policy-based routing. You can set different paths or different desktops for different types of traffic. In this example, the orange is going to be YouTube. So I'm going to say, hey, send this out using ECMP across outside 1 and 2 to get to YouTube. Secondary path for YouTube. If this ECMP load balance thing fails or whatever, then go out secondary, which is outside 3 through my third ISP. But for WebEx traffic, hey, we want to send that out ISP 3. And its secondary is going to be just ISP2. So something like this could be easily configured in our firewall now using the policy-based routing engine. And there's a whole bunch of different thoughts. But the idea is that if you have an administrative policy that you want to dictate how traffic routes, I mean, traditionally routing is done by next hop, right? Like IP. What IP am I going to? What is the path to that IP? Well, if I have 3 ISPs, they probably all are that path to the IP I want to get to. So I can make decisions based on, again, on different criteria, such as the source network, such as the application type, stuff like that, to determine where it goes. And then we do different types of path monitoring as well that you can set up. So on your firewall, in that example, for 3 ISPs, I can specify a way to monitor the state of those ISPs. It could be maybe a ping to the next hop on that path. I could specify a very specific IP address that I want it to try and reach. So maybe it's if it's Office 365, I might pick one of those IP addresses and have all 3 ISP interfaces try and get to that, right? So I can start getting the metrics of those and determine like what's the round trip time for each of those paths. What's the jitter? So like what's the difference kind of between fast and slow for each of those? How many of those pings don't come back, right? So there's different criteria I can set, and then I can use those determinations in my policy-based routing and have it dynamically send it to whichever path is considered the best. This is another thing worth mentioning for branch deployments is we, in 7.2, we have rolled out the Umbrella DNS connector for FTD. So again, main campus, if I'm running Umbrella, apologies for those of you not running it if some of this doesn't make sense, we have this concept of like a virtual appliance with Umbrella, where you can handle all of your DNS queries internally and then securely tunnel them up to the cloud. If I spin up a branch, do I really want to backhaul all my DNS traffic to my main DNS infrastructure? Wouldn't it be nice if I could just kind of go straight to Umbrella? Branch locations also tend to be maybe smaller, so a single policy for that whole branch might make sense, especially if it's security-focused policy like blocking malware and phishing. So inside of FMC now, you can actually paste in a couple API keys and secrets from Umbrella, and it will essentially build a tunnel to Umbrella for sending all the DNS traffic to dynamically. When you do this, it will start intercepting every A record request it sees on the firewall and sending it to Umbrella. You can specify like local divisions and stuff like that, so that we're not sending your internal intranet lookups to Umbrella.
Does that mean the firewall actually is, it intercepts the traffic, or it is a DNS server, or pretends to be a DNS server?
It essentially intercepts the traffic, and it will send it to Umbrella, and it will get the the policy evaluation. Basically, when you connect it, you go into the configuration of that, and you tell it which Umbrella policy it should enforce for that firewall. So what's cool about it is even if you had someone trying to go to like 8.8.8.8 on the network, it would still intercept that A record request, send it to Umbrella, and it would reply to that client as if it was Google in that example. But it's still kind of intercepting and enforcing DNS for you. So that's all doable from the firewall. You do, again, select a single policy for the firewall, but I think it's especially good for like a branch design where you don't have the ability to spin up a VA or anything like that, any of those other pieces from Umbrella. So the next thing we'll talk about a little bit is data center threat protection. How many of, unless you don't want to say either way, but show of hands, is anyone doing like data center segmentation across their network from maybe user land, so to speak? Yeah, it's I see it about 50-50 still, but it's interesting, right? I mean, there's places I always think of universities as an example where you would have students that when they connect maybe even their laptop on the dorm potentially have access to your entire data center, which is pretty interesting. Now there are people that segment the dorms and stuff off, right? Yeah, it's a pretty interesting scenario, and it's not necessarily super easy just to drop a firewall in front of your data center because you have maybe a bunch of routing stuff and you got all this thousands of workloads happening, right? And you have to kind of take your time to make sure that things go well. So the data center kind of has a couple interesting concepts. There's a north-south kind of concept, but we might term it east-west in other scenarios, but for the data center, right, there's in and out of the data center, kind of north-south zone, where a secure firewall can work really well. We also have, within the data center itself, kind of east-west, right? How do these different application servers talk to the web apps that they're using? How do they talk to the databasing? How do they talk to tools or management systems that are all sharing one big data center? And how can we look to maybe segment those inside of the data center or even inside of a single VLAN? So we have different solutions, firewall solutions, for doing different types of data center segmentation. So north-south, I mean, the classic solution would be our secure firewall. You can do threat inspection at the edge of the data center. Probably not URL filtering, but being able to do maybe some of the snort or malware inspection, and then just even having your kind of layer 4 and layer 7 based firewall rules is a really good idea. Make sure people can only use the resources that they need access to and not to all of your data center. For east-west, we can certainly use secure firewall. We see some customers that maybe will have different VLANs as different data interfaces or sub-interfaces off of the firewall, so that different kind of sections of the data center are still passing through that inspection point. We also have a service or a feature called Secure Workload, which is a primarily client-based solution that lives on the server. It can learn and understand all the processes or workloads occurring on that server. And actually, you can run it in like a learning type of mode where it's just simply mapping out all the connections they make. How many people have installed a piece of software from a small developer in your data center, and you're like, all right, now let me put the firewall rules in for it, and you call the developer and say, so what ports and IPs is your thing accessing? And they say, well, we just need port 1024 and above to the internet. Or they'll say, oh, I don't know, no one's ever asked me before, right? I mean, I think we've all probably been there. So secure workload's pretty cool because it'll just learn that, right? And then once you feel like it has a solid baseline of what those communications are, you can kind of stamp it in the enforcement mode. And since secure workload is client-based, if you move an application into the cloud, it already knows how that application behaves. That client can live in the cloud as well. We also have unique integrations with Kubernetes. So if you're doing containerized-based workloads, it can live within the Kubernetes layer itself, outside the containers, but still do enforcement there. So it's a pretty cool, flexible framework for being able to do micro-segmentation, certainly, or just more broad east-west segmentation across the data center. So some common scenarios in the data center, we have a lot of people that will deploy, instead of running our firewall as a firewall, they'll deploy it as like a either transparent-based firewall or an inline kind of bump in the wire. And that's nice because you don't have to have the firewall acting as the router into the data center. It's simply that silent security device that's kind of, bump in the wire, so to speak, doing enforcement, blocking the bad stuff that it sees. We do have some people that run our secure IPS passively as well outside the data center using span or tap ports. So that's another option where you're not going to get prevention. If you do this, you want to have someone that's looking at these alerts. The last thing you want to know is that you got a big breach. It's been alerting for 10 months and you just didn't look at the console, right? So I caution you there. If like a Fortune 500 or something, right, they have 60 security people, and one of them is going to be tasked at looking at that every day. But there are scenarios where that makes sense. We talked about encrypted traffic at the edge. A lot of traffic still is kind of plain text inside of the network, especially SMB. So there's a lot of these kind of underlying protocols that I actually think that an out-of-band or passive IPS is more useful these days in this spot in the network than it is at the edge. This is pretty cool for anyone running inline IPS deployments of our firewall. So again, not if you're doing a full firewall. If you're doing the routing on the firewall and all of that, do not do this. But if you're doing an inline, you have like a failable wire inline set, you're doing the classic like bump in the wire IPS. 7.3 and later, well, 7.3 is the only one right now, but you can go into your profile, the profile configuration of the firewall, and there's a place where you can select the performance profile called IPS Heavy. So under the hood, we have two broad engines running under the hood for our firewall. We have Lena, which you could translate that as ASA. So under the hood, like all your layer 4 stuff, all your VPN, all of those kind of tasks we've been doing for decades, is handled by the Lena engine, which is, again, kind of like the ASA engine under the hood. Everything else is handled by the SOAR engine, which is your security intelligence, your URL, your application stuff, all the cool new bells and whistles around encryption, IPS, all of those things are handled by SOAR. If I'm a bump in the wire, I'm not doing any of those classic things. I can't VPN and do a bump in the wire. I can't route with a bump in the wire. So you can select this, and it will actually allocate a heavy share, about 2/3 of the cores, to snort, which gives you more throughput on the box based on what the data sheet numbers would tell you. So that's pretty cool. On the flip side, if you're doing like a VPN concentrator and you're not doing IPS or anything on that box, it's like a specialized kind of deployment just for VPN and no firewalling, you can use those other profiles as well, which will give more of the ports over to the ASA side that's handling VPN for you.